Hacking Exposed, the #1 book on hacker methodology. Mr. Michael Davis.
First I'm going to start off talk about who I am, talk about what is a client honeypot, talk about some of the client honeypot techniques that have cropped up in the past year or so as this technology has been starting to form. We'll talk about the pros and cons of these techniques and the technologies that they're using, and then also talk about the future and actually an architecture that I've helped create with the HoneyNet project for a new type of client honeypot technology, and then at the end we'll go ahead and handle questions. So I apologize for being a little slow. My laptop, as most Windows machines do, froze, so I had to restart it. So who am I? My name is Michael A. Davis. I'm CEO of Savit Technologies. So Amy actually introduced me working at McAfee, but I did leave McAfee a few months ago. There I was senior manager of research and development. But now I run my own company, and we have a team of about 10 people that focus on HoneyNet technologies and deploying those technologies for enterprises and governments, as well as application development in general. I'm also a published author. I contributed to Hacking Exposed, which I think many of you know of. I also have some things in IT Auditor Magazine and Sage Magazine as well. And then I've spoken at a whole bunch of different conferences, DEF CON, TourCon, CanTech West. And I've also developed Snort for Windows, vSniff for Windows, and ngrep for Windows, as well as most of the Windows HoneyNet tools that you may see on the Windows HoneyNet sites. And I'm a senior member of the HoneyNet project, and that's who I'm representing here today as we start looking at these new types of HoneyNet technologies that are coming out. So what exactly is a client honeypot? It's a new term. What does it mean? Well, the age-old term of honeypot in general meant something that lied, that had value in being probed, attacked, and compromised. So we wanted to put something out on the network that somebody would break into, we'd watch them break into it, and then we'd analyze why they broke into it, how they broke into it, and then try to take those things that we learned and apply them to our own networks to see if we can improve our own security. Well, client honeypots are the inverse. They're the exact opposite of a honeypot. We're not sitting there waiting for something to come break into us, waiting for an attacker to come send us a new exploit or something like that. Rather, we're actively going out onto the internet. We're crawling the internet, searching for malicious websites, pornography websites, news sites, whatever it may be, that are exploiting the client application. And this application may be Internet Explorer, it may be Office, it could be whatever you want. And exploiting that application to do something it wasn't designed to do, or the user didn't want it to do. So the example would be downloading malware, a porn dial or something like that. So we build these systems to go out there and find these sites that are distributing these pieces of malware. So why do we need client honeypots? Well, this morning was actually a great presentation of why we see Microsoft increasing a lot of their security in the user land section of the operating system, and they're starting to prevent a lot of anonymous, unauthenticated attacks in the system. Same with all the Unixes out there as well. So what has happened is the attackers have moved to the client, moved to the application. I can't get into your machine by breaking into it remotely. Maybe I can fool you into running something, or fool you into going to a website that'll make you download something so I can control your machine or do whatever. And we've seen this. In 2005, there was only 5 Office vulnerabilities released, and this number comes from Security Focus. But in 2006 so far, there have been 24. We've seen the researchers have moved now from server-based attacks focusing on the network services and moved more towards the client. So we're talking IE, Office, Outlook, whatever your other client applications may be. So 89% of PCs infected with spyware is another statistic that came out in Q2 by Webroot, which is the #1 spyware vendor. Now, I could be, of course, slanted because they are a spyware vendor, but my time at McAfee shows me that that number is probably close to what it really is. PCs are getting more and more infected with spyware, and most of our dealings with family, what do we have to deal with when we talk to family? It's spyware, it's malware. Now, why is that such a problem? Because there's money in it, plain and simple. And so the client is where these attackers are starting to move to. Identity theft, which is huge, and it's becoming bigger and bigger. You need the data off the machine, right? So forget breaking into the machine. I need to get you to give me information, whether it's a phishing attempt, whether it's something different, to provide credentials. And as we see in the top 10 SANS vulnerabilities, and when they categorize them, 4 out of 5 are actually on client applications, so Office, IE, etc. and then operating system vulnerabilities in general are decreasing. So we're seeing a large number of operating system issues dropping away, more researchers moving towards the client. So we need these client honeypot technologies to help us get an edge on where things are going. Who are the bad guys? How are they distributing this malware? And how can I protect myself better? So the two types of client honeypots follow the same type of categorization that we do with normal honeypot technology, which is high interaction and low interaction. Now, high interaction is what I categorize as something that does, it drives the browser directly, it's not emulating anything, and it's doing a very in-depth analysis of the system to determine what happened. It's not just saying, okay, I found an exploit or something on the site that I've heard of before. It actually does an in-depth analysis of the machine to determine if it's been broken into. And high interaction honeypots can find zero-day attacks as well as known exploits. So these things are not just signature-based, looking for things that everybody knows about. They're finding the newer attacks, things that websites that have new types of zero-day exploits to make you download some malware, they're finding as well. Now, they usually require a virtual machine, whether you're using virtual PC or using VMware, requires some type of virtual machine technology so you can easily roll back to a state before when your machine was clean after the attack has taken place. Now, low interaction is sort of the low-hanging fruit when it comes to this type of technology. It's usually signature-based, so you could be using an AV engine or something to analyze what's happened to the machine, or is this script I'm going to execute, this JavaScript, malicious? But they're very, very fast because of that. They're not looking for changes to the system. They're not crawling across the file system. They're not looking at registry changes. And most people call these like the WGIG of the client honeypots. They're very simply going out there, grabbing doing an HTTP request, grabbing the response, parsing it, and then going on to the next one. And so there's very little analysis here and very little information you can get from these, but they do give you some information, and we'll talk about how they can be used later. So what can these really detect? Why do we care about these? Well, again, it's application level exploits. So i.e. being exploited by, say, a WMF exploit or a JPEG that's messed up and causing you to execute code you shouldn't be. Cross-site scripting issues, specifically spoofable address bars. That was an issue in IE. I think it was earlier this year. So phishing want to use these things. They want to make it look like you're going to a site you shouldn't be, or you should be when you're not. Malware delivery in general. So as Thorsten talked earlier, Thorsten's a member of the HoneyNet project as well. Malware, it's huge right now. Botnets and bots are the biggest thing right now out there because money is into it. And when money comes into things, you're going to see a big increase. The content analysis that comes with malware is really the issue. We're starting to see more and more, and I feel we're going to see more and more, away from just statistical analysis or technical analysis of problems and more towards content. What does this mean to the user? It's going to become very subjective. But client honeypots, because of their subjectivity, can be very useful depending on what type of data you're looking for. A great example we'll talk about later is the Site Advisor service acquired by McAfee earlier this year. They use client honeypots in a unique way to give you data that you probably wouldn't have thought of you could get from a client honeypot. I'm going to stop this before it keeps annoying me. Alrighty. So high interaction. Let's talk about the pros and cons real quick. I mentioned differential analysis provides in-depth details. What does it really mean? Well, a high interaction honeypot is doing a simple operation. It goes to a website. Once it goes to a website, before it goes to it, it baselines the system. It says, what executables do I have? What directory structure do I have? What registry do I have? Goes to the website, and then checks to see if there's a difference afterwards. So you can see that this is very, very slow. But it gives you all the information. You know if you went to a website and it exploited your browser, for example, and dropped a piece of malware on there, that malware was executed, and now you have 14 other pieces of malware running on your machine, you can see where those files were dropped, what registry changes they made, how are they hooking into the system, etc. You get a lot of detail. And these can also be extended past the browser because they're driving a program. They're not just issuing an HTTP request. They're actually driving an application by clicking on GUI buttons, by forcing Internet Explorer or forcing Outlook to open a message, that type of thing. So they can be extended into email, into Office documents, into other client applications. Now, right now, most of the HoneyNet or client honeypot technology is focused on the browser. But I'll talk about later how we need to expand that to focus again more on not just the browser, but any type of medium coming into the user. Whether this is an IRC communication or this is an email communication, maybe an AOL Instant Messenger, message coming across. We got to look at all different types of ways a client can be used to give the user information. Because it does require a driver to run the application, it's It takes a little bit more time to build these. They're very expensive to develop. There's been only 2 I know of that have been built, and they've been very extensive, take a lot of time and research, one done by Microsoft, to really build these systems to be scalable to get the data we want out of them. That's because there's so much application development going into clicking buttons and analyzing file systems and this type of thing. Now, low interaction, as I mentioned before, is very simple to build. It's very low cost. You get wget, you get a Perl script, you put them together, and there you go. You got a low interaction client honeypot, and you can start doing manual analysis. But they really don't give you much data without manual analysis. So when we talk about what data we want to get out of this, it's going to be very difficult to automate it with a low interaction approach. It requires signature research. So unless you got an antivirus vendor in your back pocket, or you know a buddy who's giving you signatures early, you're not going to know about these issues until after they're already a problem. And if you're looking at things that are already late, you're never going to find a 0-day. Maybe you don't want to find 0-day, but that's something you need to be aware of when you pick these. It can be intensive to build these signatures. A lot of these client honeypots maybe rely on AD or Snort, which is a good example. Those signatures may not be the best ones. They may not work too well. Or you may want to build different ones, looking for something different. These are very scalable, though, because they are so simple. They can easily be put into hundreds of machines across the world and start analyzing URLs and websites very quickly. But they don't work well with non-browser-based applications because you need some type of protocol you can emulate very easily. Email and email interactions are a little bit more difficult than a simple HTTP GET request. Not very, very much difficult, but still something that not a lot of people jump at right away. So I'll go ahead and talk about 4 of the major current client honeypots, and these are ones that you can utilize in some way, shape, or form. Honey Client and Honey Seeds, they're open source. You can download them and start playing with them. Microsoft's HoneyMonkey, which is a part of the Strider project, is proprietary to them, but they have a lot of white papers about how it works. And McAfee's Site Advisor is proprietary as well, but that's the key I want to talk about with data. So what is the Honey Client? Well, the Honey Client is the first open source client honeypot out there. This was set the stage, about a year old. It is high interaction. It utilizes a proxy to get all of its data. So it has an HTTP proxy as a Perl script running on the Windows machine. And it has another Perl script which actually loads up Internet Explorer, directs it to a website through the proxy, and then the proxy records all the data it gets, all the HTML, everything that it gets from the responses. It logs it all, parses those, sticks them in another file to go ahead and chew on so it can continually recurse through websites, and it just continually redirects the IE browser. So it's very, very loop-driven, and it's not a lot of collaboration. There's no external components to it. It's all self-contained. Now, the problem is that it's high interaction, so after a site's visited, it takes a long time to do a system scan. It's analyzing the whole file system, the whole registry, every single time you go to one web page. So it does take a little bit of time to actually have information be given to you. It parses the HTML, like I mentioned, which is good because it can continue to recurse. You don't have to manually keep feeding it URLs from either a search engine or some big list you're compiling. But because it only detects file and registry changes, it doesn't catch everything. So it's not looking at memory signatures, it's not looking at what system state changes. So if something happened all in memory, you may never ever see it. It still does require manual analysis once you get down to things. Once you get the data back, it really doesn't tell you what you're getting or what you're looking at. You don't know what bot it is, you don't know what piece of malware it is, you just know something happened. So it still requires a lot of manual analysis, and there's no caching. So you have maybe 50 or 60 of these sitting in your network doing a little research for you. They can all hit the same site at the same time, and there's no communication between any of the devices to sort of collaborate on what URLs are accessing, what websites they've already accessed, when's the last time they accessed them, etc. And then all of these 4 different client honeypot technologies I'm talking about are all based on URLs in the web. So none of them have access to email really, none of them have access to any other type of medium like IRC or anything like that. They're all based on the web. But the one good thing about Honey Client is that it's open source. So go download it, go play with it. It runs Perl. It's pretty simple. It is only Windows-based right now, though, because it focuses on driving IE, and that's really where all the vulnerabilities are anyway. Now, Microsoft came out, I think this was about a year or so ago, as part of their Strider project, which is a big security research project they have, a tool called HoneyMonkey. And really it was, I think, derived from the fact that IE7 had this requirement for a phishing filter. I don't know if you've seen IE7, but it supposedly has the capability to help you as a browser know you've gone to a site that could be a phishing attempt. Maybe DNS spoofing or whatever it is happening, and it alerts you right away, this is a phishing attempt. Well, the way it really does it is by using this technology to create a black and white list of URLs. So what happens is Microsoft has this big distributed client honeypot network that's using high interaction technology. It's actually taking a virtual machine with IE on it, going out to a website, looking to see if it gets infected. If it does get infected, they take that URL and stick it on a list that gets distributed to people through Windows updates within IE7, so that if you're using IE and you go to a website that's bad, it'll pop up a box saying this is bad. So really it's just a very interactive blacklist is what you're getting. Now what's nice about it is that although it's slow, their use of virtual machines enables us to actually be pretty good analysis engine. They have used the other two Microsoft research projects, the Strider projects, called Ghostbuster and Gatekeeper, to build a pretty good system scanning capability. They can detect rootkits, they can detect malware, and they can detect what type it is, what it's doing. Very, very in-depth information from these two other projects. And that allows them to scan memory in addition to file system and registry, do really in-depth checks of what's happening. That coupled with the virtual machines they have allows them to easily detect 0 days by running the same URL across a set of virtual machines. One virtual machine could be configured with Windows 2000, one with XP SP1, one with SP2 fully patched. They can see if the same URL infects different hosts. And if it doesn't affect 2000, but it affects SP2, well, now it's giving them more information on how this piece of malware works, how this site is targeting users. Maybe they don't want the Windows 2000 users, maybe they only want the XP SP2 users, or if it doesn't work on the fully patched machine, well, it's not 0 day. If it does work on the fully patched machine, hey, it's something that our patch didn't fix, we need to look at this. So they can find 0 days with this as well. Now, from my interaction with the Microsoft team on this, which has been very little, it doesn't seem like it's being used very much. They have a pretty good idea. They built a pretty cool farm when they originally built this to get some good metrics. But in general, it's just being used to supply the IE7 with their information. Now, that may be wrong, though. Now, HoneyC is a relatively new appearance on the open source stage. It's low interaction, very simple. It basically is doing the wget request that I talked about earlier, but it's doing it in Ruby. So you give it a list of URLs, you give it, or a search engine and a keyword. It'll go out there to execute the URL or the search and get a list of that and keep feeding it in there. And as it downloads the HTML page, it just runs it against a list of snort signatures. So it's relying upon snort and the bleeding edge snort rules to find these malware downloads, these malware issues. So it's very reliant upon other technologies and on the signatures that are used in snort, which any type of, anybody's used snort from the bleeding snort rules list, they don't work all the time, so we can have issues. And the URL seed, again, is search engine based, which in my mind is a very bad way to go about starting your seeding. It is very just, throw something out there and hopefully you catch a fish. Well, I don't think that's a good way to start your prioritization of looking for malware. And there's no caching or correlation done like Honey Client. There's no cross-correlation of what URLs have been visited, what I found at this URL, when's the last time I visited. There's no information and no use of the data at all. It just sticks it into a log file and it's up to you to really look at it. Now, the sort of the granddaddy in my mind of client honeypots is McAfee's Site Advisor. And really, nobody's talked about it as a client honeypot, but that's really what it is. If you aren't familiar with McAfee's Site Advisor, it's a very simple application that goes out to websites, sees if it gets infected by anything, and by infected it means it actually uses antivirus to determine if it's been infected. And if it has, it marks that URL as bad. And then you as a user have a plugin built into your browser that when you go and do search engine searches or you go to a website, it tells you if this site has been ranked good or bad. Has it had people downloaded malware from this site before, yes or no? And that is empowering you as a user to not go to that site because, hey, there's been phishing attempts there. Now, they also integrate email and spam into this equation, but in general, it's just doing a massive web crawl and analyzing what's happening to the client when it goes and visits this website. Now, they built a very, very scalable, high interaction client HoneyNet. And this is a massive deployment, very, very big, but they focus on the data, which is what you guys are concerned with and what I am concerned with in the end too is, okay, I accessed this URL, I got infected. I have this piece of malware on me. What does that mean to everybody else? How can I help the community, or how can I understand that if I go back to this site and get infected again? And so it can tell you, this is a bad site, don't go to it, or somebody else said this is a bad site, but we checked it out and it's not, right? So you can get some more information. It does utilize signatures because it's based on AV. So this is why McAfee was a good fit for them. It requires the latest AV signatures to determine have they been infected. But they use the community to double check their data. And I mentioned how a user could say this site's bad, but they check it's not, and vice versa. That's the first we've seen in this type of technology of a feedback loop. And I'll talk more about how a feedback loop is essential to this type of technology because what we perceive as bad may not be bad to somebody else. And then they also use email as well, which I'll talk about why that's needed as well. So what's the future of these things? We talked about 4 brief ones. They're very, very basic. There's not much been going on. We have this amazingly open technology here, but everybody's been focusing on the tools, building cool little widgets that do things, that go out and download sites, and everybody's been focusing on that. And really only Site Advisor have they focus on the data. So the first thing we need to do is branch out more. We need to stop thinking about browsers. We need to start thinking about the client application in general, email programs, Office, Excel, PowerPoint. There was just a PowerPoint 0-day or something I saw on the mailing list or whatnot released. So there's other client applications that are being infected that we need to be concerned with. IE and Mozilla are not the 2 big targets anymore. But we need more data. We need to take this data, we need to collaborate it across multiple different types of data. So Site Advisor uses the data in one way, but that same exact data could mean something totally different to you. For example, they use it to determine if the site's bad. Well, I want to determine what type of malware is being delivered from that site, and if I link up the authors of those malware, and maybe who owns the domain, am I able to find out some information on that? Geolocation information, things like that. Other data that could be useful to other entities derived by doing this type of technology. And then open community for data analysis. This is something that I want to help build with the Honeynet project, is if I have my own little Honeynet here of client honeypots gathering data, and you have yours over there, and somebody else has theirs, how do we put our data together? I'm crawling this part of the web, you're crawling this part of the web, and the web's huge. So how do we go ahead and consolidate this data together to learn more about it, and to learn more about the malware that's being downloaded, the exploits that we're seeing, and things like that. Now, tools are not the answer to that, so I'm hoping that we'll be able to use these tools and realize that they're a means to an end and not the end goal. And then also use more tools to build automated analysis here. These communities can be fed data, and a lot of information of this data can be automatically analyzed and determine, have we seen this malware before? If we have, what information about it do we know? Is it linked to another site, etc.? So there's lots of data. Now, where do I want to go? I've analyzed these 4 sort of a client Honeynet technologies that are out there, and so I have my own ideas here. So these are purely my own ideas of a client Honeynet and a honeypot that I will be building for the Honeynet project. I don't have a demo right now, but it's actively being developed. And one of the main goals was modularity here. As you saw with all the other 4 different projects, they're all focused on URLs or driving the browser integration, that type of thing. What I want to be able to build here is a modular structure that can take inputs from anywhere. So perhaps I'd like to take my spam filters. I'm now blocking all this spam. I know it's spam. Well, let's extract the URLs and see if I put that URL into my system, if I go get infected by going to look at this Viagra pill or whatever it may be. So take a lot of different inputs into the system as opposed to just a static list of URLs I feed it every day. Make it autonomous. Make it grow on its own. So I get email as an input. I can get Craigslist postings. I can get eBay postings. I can get things like that I can sort of feed in that'll help drive my URL searching. It definitely has to be high interaction because of the data we want out of it. One of my goals with this is to get as much data as possible to the function level. I want to be able to see what function calls were executed by the malware after it was downloaded. So I need to know things like what type of malware this is with all the packers that these various bots are using. I can't just do an MD5 of the binary and say I've seen it before. I want to see what it's doing. Is it a variant? Is it what is it doing to the machine? And be able to get that as time's going on. Thorsten talked about in his talk earlier today about a method for doing this with CW Sandbox, and it's a similar type of idea. Letting an application run for a little bit of time, gather some information on it, and using that information to further our research. But one key piece here is utilizing low interaction client Honeynet technology in this high interaction honeypot. So there is a value in these low interaction tools in that they do some cursory analysis. If I can easily do one simple request, match it with a signature that it is this type of exploit, well then I can take that data, know that it is an exploit, know that it's categorized as something over here, and then as time permits, feed it into my high interaction system to get more detailed data. So you can use low interaction plugins for your essential gathering and assessment of certain sites. Does it pass the sniff test essentially? And then build a community through the HoneyNet project, through the HoneyNet's website and the HoneyNet's alliance of members to help take this data and build the data. So there's a alliance project within the HoneyNet project, which is a grouping of people all around the world that put data together and analyze it. And so we'd like to build on that with this type of data, client data. And then also I'm envisioning a distributed IE plugin, which is the last step to this whole process. This IE plugin, I got the idea from McAfee's Site Advisor, but a little bit different. Instead of the plugin telling you a site's bad, the plugin can actually execute these little quick signature-based no interaction queries for us, as in us being the project. So you're browsing as you're going to CNN, you're going to different sites and whatnot. It is just a signature-based check of what site you're on, determines if anything bad happened, and if it did, it just logs and records it, and then you can submit that to our system as you like. Now, this distributed IE plugin keeps our data current, which is a problem that highly scalable systems have. They're trying to go out and get every single URL out there. They just want to get the whole web. Well, the problem is the whole web doesn't matter to most users. You have a set pattern of websites you go to, a set pattern of sites you trust. So the question really isn't, is this URL that's way off that only one person's accessed in 10 years going to infect me? It's more of, well, is the site Amazon.com all of a sudden got an issue and I just got infected with something? So there's that type of situation. So a distributed plugin built into a standard user's operating environment where they don't even realize it's happening behind the scenes can help us get a lot of current and relevant data. So the general architecture of this is very simple. Follows the Gen 3 architecture from the HoneyNet. Now, you may not be familiar with that. It's very simply just your standard central server to receive all your data and a whole bunch of sensors across the world. The centralized collector is needed because when you have these one-off systems just sitting there running and chewing on URLs, they can go over the same URLs 10 times and not even know it. They can be seeing the same malware 100 times and they have no intelligence built into them. So the centralized collector can help correlate URL lists, can help reduce duplicate data that we've seen, decrease the number of actual assessments that have to be done on the sensors. It can provide a list of URLs to clients. So maybe we're going to take in that spam feed, or maybe we're going to monitor an IRC chat room for URLs that pop up and feed that into our system. So that feed can come from the centralized collector and be distributed out to sort of the drones to do the work. The community, like I said, visits the same sites over and over, but not the new ones. So the centralized collector can be the way to get the new sites out there, while the community is building, are continually going over the sites every single day. There's going to be a client-side kernel filter to help determine exploitation. So the next slide I'll talk about more detail of what that is. But it's important to note that a lot of the tools right now are user mode based. They're just doing a simple diff check. You check the whole file system, check it again, is there a difference? If there is, then something happened, you should look at it. We're going to go more towards an approach that gives a little bit more scalability, a little bit more capability to determine really was I exploited or was I not. Now, the general approach for these things has been a simple, diff check, like I mentioned. There's been some talks of moving into this, away from the signatures into something more advanced, because those signatures are very content-based. They very simply just go after, whatever's there. They can't understand JavaScript, so if there's a time bomb in there, so for example, you have a JavaScript command that says, wait 4 minutes before executing this code. Well, in a general signature-based thing, it may not be looking for that time bomb to redirect you to a bad site. It just says, oh, there's nothing there. Or if you have a general system where it's just monitoring what the browser does, a time bomb can cause an issue because you may have already browsed away from the site before the exploit occurred. So what we try to devise here is a client architecture using a kernel filter driver to profile IE, similar to Neil Provost's systrace functionality. We basically baseline IE and say this is what it generally touches. It touches these directories in the file system, touches these folders in that directory, and that's about it. So anything out of this very simple baseline is in an exploitation. And since we're controlling both the operating environment and the browser in this situation, we have full control. That baseline can be a pretty accurate baseline. So any functions executed outside of this profile need to be examined and cause basically an alert. Now, if you've heard this before, it's because of the standard HIPS approach to sort of monitoring your application and your machine. So taking the same HIPS-based approach, which is a host intrusion prevention, but instead of alerting or preventing the operation from occurring, we're just going to log it and then take that information and feed it back into our system. and go ahead and start looking at the binary to see what happened. Now there are problems with this architecture we've come up with. There's a couple of them. The application profile can be wrong, so the baseline that we're coming up with can be wrong. It can't. Maybe it's too open or it's too tight, and so everything's tripping. It could also be that we won't catch the in-browser exploits. What I mean by that is things that actually match the baseline, work with an IE, but we subjectively consider invalid use of the browser or a malicious attempt at the browser. So an example of this would be phishing, IP address spoofing. We may not catch this, very easily. But we can watch for things that affect the machine state, which, for what I'm looking at, for the data we're looking at, is really the big key here. We're looking for malware, binaries, and bots that have been dropped. Okay, good, all right. So we're looking for the malware and the things that have been dropped on the machine, more so than just the standard web pages. And then, of course, this architecture is not cross-platform, but the question I pose is Unix even a client problem? Is there an issue with Unix clients? I don't think it's big enough of a market, really, that anybody's targeted for that. So it's not going to be cross-platform. It'll probably be C#.NET based type of solution. So that's it in general. It's very amateur technology. There's not a lot happening with it. My goal here was just to introduce you into some of the things that are happening, so as you start seeing these terms being used, you have a better understanding of what's available, what that really means, what kind of data they're getting, and just introduce you to sort of where things are going in the future. There's a lot of growth in this area. There's a couple different universities that are coming up with, I think there's 3 new open source Honey client architectures coming out in the next couple of months. University of Victoria in New Zealand, they have 2 different groups that are working on this problem. And I think Indiana University also has some interest in this. So is there any questions in general? I walked pretty fast through it because it's a pretty, I think, simple concept, but it's really the when you dive in deep where you get questions. Go ahead.
So far you're just talking about URL. So far you've just been talking about URLs. I'm just wondering if this expands to email. What about issues like privacy? And that is an area of concern because email is not so much the traffic, but the payload and the content.
When you say email, do you mean you receive an email and you want to see if it's valid?
Yeah.
Okay, well, it can easily be extended to that, and that's why I was trying to drive the architecture modularity. Right now the focus on email has been as an input mechanism into our URL parsing, but nothing prohibits you from using an email to see if there's an exploit within the email. And there can be systems that can do that, and this system could be extended to do that, and that is the goal. We don't know what the next things will be. I'd like to be able to scan Word documents as they're open to see if there's any macros, and then actually crawl the web downloading Word documents. So do a nice simple Google filter search on, say, job application in a Word document and see if anything has any macros in it that are bad. So there's lots of possibilities going forward, but right now we're still at the same level of building the architecture. And some of the architectures in my mind before were too limited to even start thinking of that. Anybody else have any questions? Go ahead.
Yeah, science fiction question. Let's say we're not using Microsoft.
Mm-hmm.
Let's say everyone all of a sudden is using Linux.
Mm-hmm.
What do you think this scenario would look like? Same sort of exploits being developed?
Yeah, I think it's going to be the same thing. I mean, it's the same technology, just somebody else wrote the code. So Mozilla Firefox is an issue, and we're going to have to look at that going forward here. How do we address it? Right now, Mozilla, the plugins aren't so well known. It's not as easy. It's easy to integrate with. They have a good API, but nobody's built anything for it yet. And there's not enough to get people interested as of yet. I'd like to do more research in it, but right now we got to go with the low-hanging fruit, which is Microsoft. But the technology in general will apply to anything. It'll apply to Unix, it'll apply to Macs, it'll apply to anything. You just have to have the code to build it to do the assessments.
So it's an economic question, basically.
Right, exactly, yeah. Right now it's a very research-driven technology. Lots of research, and there's really, besides SiteAdvisor, they commercialize it, but they commercialize the data, not really the technology. So right now, until we get more proof that this is a good technology, we won't be going into those different areas.
Thanks.
Anybody else? Any questions in general on HoneyNet technology since I'm here? All right, well, I thank you guys, and I think you got out early for a coffee break, so that's good.